Alright, section 2.3, we're going to talk about polynomial functions, and they're defined by f of x equals, if you would just take a minute and read through this, where n is just a non-negative integer, and the a sub n minus 1, a sub 2 are just the real numbers. It's called a polynomial function, where the coefficient of the variable to the highest power is called the leading coefficient. So we're going to just get you familiar with some of the notation and some of the definitions first. And the easiest way to do that is to look at some specific examples at first. So it says, determine whether the function is a polynomial function. So we want to know if it matches this similar format. And in this first particular case, we would just say it appears to be in that same format. So we would say, yes, this is a polynomial function. And the leading coefficient, can anyone guess the leading coefficient for me? The leading coefficient, this is going to be our leading term because it has the highest power, x to the 5th power. This is our leading term, and the leading coefficient would just be the 2. Okay. Let's look at number 2. Does this format look similar to this format? No, it does not. And why? Because it has that division by a variable on the bottom, and that's going to be not a polynomial function because it needs to match this format up here. All right, what about number 3? Actually, this one is. This one's 5x to the 7th power minus x squared. This is really just, the coefficient is 5/4. It's x to the 1st power. So just the coefficient's a fraction. That's okay. So we would say, yes, this is. And the leading term would be 5x to the 7th, and the leading coefficient is going to be the coefficient of that leading term, which is just going to be 5. Okay, and let's look at number 4. F of x equals x to the 5/4 power minus x to the 4th minus 7. What do you think? No, but why? Because this fractional exponent right there, so we would say no. Okay, so we just looked at a few examples, some that were polynomial functions and some that were not. It's easier to remember the things that make it not a polynomial function. So division, so this case right here and this case right here. Alright, polynomial functions of degree 2 or higher are smooth and continuous. Smooth meaning that only rounded curves and it has no sharp corners. Continuous means no breaks. Basically, you can draw it with your pencil without having to lift your pencil up. So I'll give you a few minutes to just look over these graphs, and I want you to tell me if you think the graph is a graph of a polynomial function based on properties of smooth and continuous. What do you think about this first one? No, why would you say that? It's not smooth. It's not smooth. Good. What about B? Yes, and I wouldn't have to pick my pencil up, so we would say yes, this is a polynomial function. And what about the next one? No, that's because when I'm going along here, and if I wanted to continue my graph, I have to pick my pencil up to come back here to start it over again. So this one is no because it has breaks. It is smooth, but it has a break. So we would say no. Now we're going to talk about the end behavior. What happens at the ends of the graph. So it may have intervals where it decreases or increases, but the graph will eventually rise or fall without bound. So basically, if this is our leading coefficient test and we said we have a polynomial in this format, okay, we have some definitions, some properties to use. So I'm going to pause it and take a few minutes to write it down, and then we'll pick up from there. Okay, so pause the video, make sure you get that down, and what we're going to do on this next step is look at an example and put this information to use. Alright, use the leading coefficient test to determine the end behavior. The first thing we want to do is find our leading term, and we want to look at that. And we want to determine the exponent of our leading term, which is going to be a 2. Is that odd or even? It's even. Therefore, if it's even, we know it's going to have the same behavior. Either the arrows are both going to finish up or the arrows are both going to finish down on the ends. So my thought process is they're both either going to be up or it's going to, actually I don't need to leave it as up, or they'll both be down. Okay, the end functions. Now we look at the coefficient in front, which is now, this is what we look at. This is a positive 2. So if it's a positive 2, then we say go to the a sub n is greater than 0, so it's positive, so we know that they both finish up. Okay, so that means we're dealing with the case where both ends finish up, and we would just say rises, rising left and right. Rising on the left and rising on the right. Okay, let's look at number 7. We first identify the leading term, which is this value. Okay, that's this term right here. That's the leading term. Now we're going to look at the exponent to determine if it's even or odd. And what do you think? Odd. The 3 is an odd number, so it means an odd number has opposite behavior. So that's easy to remember. Odd, opposite. That means it's either going to be one's going to finish up and one's going to finish down, or vice versa. Now we got to figure out what that is. We know it finishes opposite, but then we look at this number and it's negative. If a sub n is less than 0, that means it's negative. We have it finishes down. That's how I want you to remember it. Finishes down. So when I see this, I'm going to say odd means, basically my mindset when I'm thinking my way through this is I would say, okay, odd means they're going to finish in opposite directions. Negative number means it's going to finish down. So if I'm going to, it may finish something like this. It's going to be opposite directions and it finishes down because this is a negative number. That's not necessarily the shape of it, so it's usually better just leave the middle out and just have yourself a note like this. Starts up, finishes down. So we can say falls right and rises left. Or if you want to change the order, you can say rises left and falls to the right. It means the same thing. Okay. So for the leading term, this is the leading term because that's x to the 4th power. It has the highest exponent. I look at this and it's even, so I know they're either both going to finish up or both going to finish down. They're going to finish the same. And then I come and I see that this is a negative value, so it's like, okay, they both ends finish down. So we say falls to the left. Falls to the right and falls left. Okay. All right, and let's look at this next one. X plus 2, x plus 3. What's different about this one in respect to the other? It's not, basically it's not folded out. It's not in that extended version. So we would have to, do you think we have to FOIL this entire thing out to then look at it in here to get a leading term? No, not really. But so if I was to, let's just say I took this x and multiplied it by this x and multiplied it by how many of those there? 3 of them. How many do we get for the first term? What's x times x times x to the 3rd power? x to the 5th power. So I don't have to pull the whole entire thing out because really in all of these, what did I care about? Just the first one, just the highest one. So of course that's going to give me my highest one. So I don't need to do all that extra work to know that this is my highest one. And fortunate for me, that was just a 1x, a 1x, and a 1x. So my coefficient is just going to be a 1. So that's nice. Now if it was different, it might be a little bit more of a headache, but we're looking at this as our leading term. Odd, so it finishes in opposite direction. And what's the known coefficient out front? Positive, so it's I finish odd, finishes opposite, and it's positive, so we want to finish up. Positive means finish up. That means if it's opposite, so we would just say rise to the right, fall to the left, rise to the right.